Our cost optimization dashboard helps organizations optimize cloud costs, focusing on desktop as a service environments. Our solution delivers comprehensive visibility and automated optimization recommendations for public and private cloud resources, helping 90% of enterprises that overspend by an average of 30% regain control of their cloud investments. With our platform, our customers gain deep, granular insights into their consumption, from the subscription level down into what each individual user is consuming. Here on the homepage, we start with auto baselining. This algorithm continuously monitors resource consumption across desktops, servers, and storage. It establishes a baseline of what normal usage looks like based on historical data, taking into account fluctuations in user activity, peak hours, and application demands, with a 95% prediction accuracy rating. By identifying deviations from this baseline, we can pinpoint underutilized resources or sudden spikes in consumption, allowing us to recommend right sizing or redistribution before unnecessary costs accrue. The homepage offers an entire overview of all subscriptions within an environment, and for our reseller customers, they are able to track their actual costs versus their customer spend. Now, moving into the host pool breakdown. In this view, we get an overview of all of the host pools within the environment, and by selecting on an individual day, we're able to break down how those host pools impact the cost of the environment itself. Additionally, we're able to filter down by host pools, subscriptions, regions, custom tags, and by any day. And we're able to export all of this to either a CSV or an Excel file. Let's go ahead and jump over to the login summary. Under login summary, we're able to review the total number of sessions by any date range, including individual days. This accounts for users disconnecting and reconnecting, which we can further expand upon by clicking into one of these tabs. Here, you can see the total number of unique sessions of 95, with a total number available of virtual machines of 12. And the second line here shows the total number of unique user logins and available VMs, which our optimization logic leverages for capacity management, which we will show here shortly. Now on to the hourly reporting view. Here, we break down the day-to-day capacity, showcasing hourly user concurrency, providing further clarity into the capacity by breaking down at which hours users begin logging in, logging off, and highlighting peak hours of utilization. And by selecting into any of these dates, we're able to further break down which host pools were contributing the most users. Here, we can see this host pool contributed 38 users of the 46 active sections. Now let's go ahead and jump over to our hourly peak concurrency view. This view narrows the focus of which host pools contributed the most to the capacity of the environment. As we can see here on this timeline, the number of users and how each host pool contributed to this. Additionally, zero login host pool view highlights host pools that have had 0 logins in 1+ week, which further providing a quick snapshot of potential cost savings. Now let's go ahead and jump over to resource groups. In the resource group view, we are given the ability to track costs associated with groups of resources. This view provides further granularity for our customers to attribute costs to specific resources or resource groups that they are utilizing. Here in this view, we're able to break down by each individual resource group and see the exact cost and percentage that they attributed. Now, let's go ahead and jump over to our resources. The resource view gives direct insight into every item within a customer's environment. By default, all of these items from virtual machines to connections are all selected, which provides us the ability to see all of the cost over each individual day for those resources. By unchecking these graphs, we're then able to break these costs down by individual resources as well. Here, by selecting virtual machines and disks, we get a total cost over each individual day. Here on the bottom, we can see the virtual machine cost, as well as the disk cost here in the pink. Within the bar graph, should there be any unallocated disks, we can quickly spot these, as they are consuming costs despite not being actively utilized. By surfacing these costs here, we provide immediate visibility, prompting action to either reallocate or detach and reduce unnecessary consumption. Additionally, we're able to break this down further by each individual day and by those resources here. Let's go ahead and move on to our desktops. Here in the desktop view, we are able to further break down the host pool overview by attributing cost to each individual desktop. And of course, we're able to break this cost down further by selecting any of these date ranges. And of course, you can see here on the right how each individual desktop contributed to that cost, as well as the percentile. By scrolling down, we're then able to get a line-by-line breakdown, including by date range. Now let's go ahead and move on over to users. Now in the user view, we are able to map how each individual user contributed to the total cost of the environment day by day. And we can take a deep dive by selecting any of the individual users to see how each component impacted the environment's consumption. Let's go ahead and take a look at Krishnan. By selecting into Krishnan, we're able to then see how the Microsoft Compute or any other resources contribute to that cost on a day-by-day basis. Let's go ahead and jump over to our Tag Manager view. The Tag Manager view is a powerful tool that provides granular visibility into resource allocation and cost attributions. Customers can group resources by team, department, or use case, or any custom category that aligns with their business needs. This capability not only helps in organizing resources, but also in identifying the cost drivers across specific segments. For instance, in this view, we can see a breakdown of costs by host pools, desktops, and users, providing transparency into how resources are being utilized and what they're costing. This level of detail is especially valuable for shared environments where multiple teams or departments are accessing the same infrastructure. Now, let's take a closer look at the Testing Tag Manager. Here, we can drill down further by filtering specific resources within that tag, such as host pools, desktops, or users. This gives customers the ability to assign costs directly to specific business units or even individual users, making it easier to implement chargeback models. For example, if a department is running multiple testing environments, they can view the costs associated with each host pool, desktop, and specific user in that tag. This level of granularity not only provides clarity on spending, but also allows for more accurate budgeting and financial accountability across departments. Ultimately, by utilizing Tag Manager, customers gain a comprehensive understanding of how each categorized resource impacts the overall spend of the environment, supporting more strategic cost management and allocation. And we import all of the Azure tags as well, providing customers the ability not only to make their own custom tags within CloudOptimal, but also the ability to import any existing tags into the environment too, providing customers further granularity across the entire environment. Now, let's go ahead and move on to our optimization dashboard. When it comes to cost optimization, we're not just looking at numbers. We're orchestrating a strategy that balances performance, cost efficiency, and resource allocation. The optimization view leverages both native cloud metrics and Anunta's proprietary algorithms, creating a dynamic framework that uncovers hidden opportunities for savings without compromising user experience. Let's begin with our AI-driven auto-scaling strategy. Think of it as a finely tuned engine that adjusts capacity in real time. The platform continuously analyzes user demand, session activity, and resource utilization. If workloads are spiking, the system dynamically scales up to maintain performance, but when demand drops, it automatically scales down, preventing over-provisioning and reducing unnecessary cloud spend. And it's not just reactive. Our AI-powered strategy learns from historical usage patterns, creating predictive models that anticipate fluctuations and adjust accordingly. In this view, we're given an hour-by-hour breakdown into the cost of the existing auto-scaling strategy, as well as the predicted cost of the AI-enabled strategy, giving customers unrivaled clarity into their existing auto-scaling models and the cost savings of the AI prediction as well. Furthermore, we're able to review the current schedule in its entirety from ramp up, working hours, ramp down, breadth or depth first. Then we are able to then review the recommended schedule as well as weekdays, weekends, and compare the existing schedule with the predicted schedule as well. Additionally, we're able to download the template to be manually uploaded to the environment, or by selecting deploy here, it will be automatically deployed and begin automatically scaling up and down based on these parameters. Now let's talk power management plans. Imagine lights in a building that turn off when no one is in the room. Similarly, we're identifying virtual machines that are running on a pay-as-you-go plan, but remain idle for extended periods. These are the silent budget drainers, the VMs that rack up costs without delivering value. By establishing power schedules, we ensure that machines are only active when needed, automatically powering them down during off-peak hours and powering them up just before expected demand. This proactive approach not only conserves cloud spend, but also extends resource life cycles. And our user disconnection and reconnection logic is applied to autoscaling and power management, a nuanced layer of optimization that is often overlooked. When users disconnect but don't log off, resources remain allocated, draining costs from no active sessions. Our system identifies these cycles, creates automated disconnects for idle sessions, and adjusts power management schedules to align with actual session activity. It's a targeted strategy that minimizes waste while remaining while maintaining readiness for users to reconnect seamlessly. And this can be downloaded to a template or automatically deployed to the environment by selecting deploy. Next, we move to zero login host pools. A common culprit for cloud waste, these are host pools that have been spun up but haven't seen users logging in a defined period. In other words, they're consuming resources without serving any users. Our systems flag these instances and recommends consolidation, shutdown, or reallocation, essentially turning dormant infrastructure into actionable savings. These interconnected strategies, auto-scaling, power management, zero login host pools, stale resources, and user session analysis, our cost optimization framework transforms cloud operations from reactive to proactive, turning inefficiencies into cost savings while maintaining a seamless user experience.